Hi people, welcome to today's lesson. We are going to talk about something that answers our last question. People were having burning questions. We were talking about if you are a non-metal, you will usually lose one electron. If you're a metal, you will gain one electron because metals, you are rich. You have extra money, you don't care, you lost it, you don't care. Non-metal, you grab it because you're poor, you grab it into your pocket. But if you are an atom that has only 4 on the outside, what do you do? So if a carbon wants to form an ion, does it lose or gain electrons? Today's learning objective is, what is covalent bond and what does covalent bond look like? So sharing is caring. When you have two non-metals meeting up with each other, they will share electrons. So we talk about when you have a metal atom meeting up with a non-metal atom, they will have a kind of lose or gain action happening. They will take away and grab another one from each other. But in between non-metal atoms, it's a sharing electrons. And we're talking about sharing the valence electrons, which are the electrons that is happening on the outside, the most outside electrons. For one example, here's our periodic table. You have the non-metals on the right-hand side, except hydrogen. Hydrogen is a non-metal because of its special property, we place it into the metal part. And the metals is on the left-hand side as well. So if you have a chlorine meeting up with another chlorine, so chlorine gas is usually Cl2. It forms in between two chlorines. But if we are talking about losing or gaining, you have 7 on the outside. You just need 1 to become stable. If you want to lose all 7, that is not very efficient. You have to lose 1, lose another one, lose 1. Every time you lose 1 electron, it actually takes up energy to do it. Same thing over here. If you want to lose 1 extra electrons with another chlorine atom, it takes a lot of energy as well. So they figured out a way. Haha, we can just share 1 electrons, right? So if we kind of do something, then everybody's going to be happy. I will simplify the whole process by using one simple atom, which is hydrogen, to introduce this process. So hydrogen, when we have 2 hydrogen atoms, we know that hydrogen, you only have 1 electron shell because you only have 1 electron. And when you meet up with another hydrogen, what do? You want to kind of share in between each other. They form a bond like this. So they kind of squeeze it in, getting close to each other, and they share everybody's electrons. So here what it looks like, the model of hydrogen. Here's the logic behind it. So each atom, you will have a nuclei. Nuclei is the singular form of nucleus. Nucleus is at the center of the atom, and you will have proton and neutron at the center, right? And proton, especially, is positive charge. Neutron has no charge. Positive charge will attract negative charge. In our atom, negative charge is our electrons. So the proton at the center will attract the electrons on the outside. Both of these protons in 2 hydrogen atoms will hold on to the electrons. So when they get close to each other, both of the protons in the center will hold on to both of the electrons. They will not only hold on to their own electrons, they will also kind of want to grab the other electrons from the other hydrogen. So you form a strong force of attraction in between each other because they're kind of like holding hands to hand, grabbing each other's electrons, and that holds a strong force of attraction. That is covalent bond. Okay, so covalent bond is a strong force attraction in between 2 non-metal atoms. And comparing to the ionic bond, which is happening about losing or gaining. In covalent bond, there's no ion. So carbon, because of the special property, will not form an ion. What it will form is a covalent bond. And another word, it is a molecule. So, and molecule is a group of atoms being held together by a covalent bond. So hydrogen is a molecule, and water, H2O, is another molecule because you have two nonmetals holding up to each other. Oxygen is another molecule because oxygen is two of them are both nonmetals. Sharing is caring. Here's one example. If you have a chlorine gas, what is that going to look like? Chlorine gas, remember? Chlorine gas. Okay, what do we do? Firstly, I want you to draw on your paper a chlorine gas. So here's what's going to happen. You might wonder, the handout of this time looks kind of different. So what I want you to do is that get a scissor. Okay, after I tell you the instruction, pause the video for a second so you know what to do. Get a scissor and cut along only this line. Okay, only this part. And you're gonna fold along this line. So pause the video and get a scissor. Okay, so what I want you to do is that we're gonna have a lot of examples in this video. So every time when I give you a pause time, you're gonna pause the video, try to work it out yourself. Okay, and then you're gonna put the correct answer over here in this box, and you're gonna cover the correct answer with the other paper. That's why I want you to cut it over here. So you kind of flip this paper and cover it your correct answer. So every time when you come to this page, you can kind of quiz yourself on how to do it mentally. Okay, so here put your correct answer and also use this one to cover it. And also pause the video, practice drawing it ahead of time before I give you the answer. Okay, now let's go back to our lesson. Chlorine gas. So you will have two chlorine atoms. What does that look like? What is it going to look like when they join together? So you will have, you can take a look. This chlorine has one singular electron. The other places has been filled up already, right? So this one is left with one singular electron. The other one is formed with a one singular electron as well. So they kind of form a pair. They join up like this. So every time when we're drawing chlorine gas or any other atoms of the outside particle that is more than 4, what I want you to draw is that you firstly draw out 1, 2, 3, 4. Okay, spread it out. And then fill it up whichever way you like, form pairs. So try to spread out your first 4 electrons and then spread up. So it's easier for you to kind of form your covalent bond in this way. Okay. In this case, your chlorine gas will form a shared pair. For each shared pair, we use one single line to represent it is a single bond. It's a single covalent bond for each shared pair. So Cl, covalent bond, and Cl. That's what it looks like. The next example is oxygen gas, O2. So pause the video and draw out what is the oxygen gas covalent bond looks like. Okay, so 2 oxygen atoms, that's what it looks like. You might have noticed already that we kind of erased the inner circle. We only draw the covalent electrons because we want to simplify the process. So you can see that right now we have one singular and another singular electrons for both of them. So they kind of form this one, zoop, swim over here, this one, zoop, swim over here, and you form 2 shared pairs of electrons. One shared pair is single bond and 2 shared pair is a double bond. So you have a kind of 2 lines in between each other. The third example is nitrogen, N2. Okay, pause the video for a second. Use your periodic table on your agenda to see what it looks like. Okay, so you have 2 nitrogen atoms. Nitrogen, remember, first you draw 1, 2, 3, 4. And then kind of place another dot over here. And now you figure out there's 1, 2, 3. 3 different singular electrons for both of them. So they kind of shoop, shoop, swim over. And then you form 3 pair shared of electrons. So every time when you draw nitrogen atoms or when you draw any atoms, I want you to use different symbols to represent. So use one of them, use a dot, the other one use cross. Okay, so that you know this is a shared pair of electrons, you know that they're kind of joined towards each other. So dot, cross, dot, cross, dot, cross, they're shared pair. And now you form 3 shared pairs of electrons. That's a triple bound. Okay, now let's make it even more challenging. Here you have a hydrogen chloride, HCl. Pause the video for a second and draw what does the HCl bounding look like. Okay, so firstly, let's draw the chlorine atom. That's what it looks like. If you only draw the outside valence electron, it's fine. And here's what a hydrogen looks like. And they kind of just need to share one pair, and life is good for both of them. The next one, you have water. Okay, let's draw out what water looks like. Okay, so now firstly draw out an oxygen. 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 of them, right? And then you have 2 hydrogen that comes along. One come here, the other one come here, and that gives you a hydrogen. That gives you a water molecule. It will look differently, depends on how you rotate your water molecule, but as long as the overall it looks like this, you should be fine. The next one is our methane gas. So CH4. Firstly, draw what it looks like. So here you can see that the cross is the valence electrons belongs to my carbon, and the dot are the valence electrons belongs to my hydrogen. Okay, so we have 4 shared pairs, and if you want to draw out the structure of this molecule, it will be a C, and you have a hydrogen for every side, and you use a line to represent the shared bond. The next one, okay, pause the video for a second, and that's the answer. So ammonia, you have 1, 2, 3, 4, 5 that belongs to nitrogen, and the hydrogen will come to each place. And next one, methanol. It's kind of hard. I want you to pause it for a second and work it out yourself. You might take a little bit longer, but it's okay. Okay, so here is our methanol, CH3OH. So firstly, work out the first 3 CH3. The carbon forms a covalent bond with 3 different hydrogen. And then the next one, you have a singular pair, and oxygen kind of forms a bridge. So oxygen will share one pair with a carbon and share the other pair with a hydrogen. CO2. Carbon, and you have oxygen and oxygen over here as well. And so over here you have 2 shared pairs, and on the other hand you have 2 shared pairs as well. If you feel like I'm still not so quite sure about this part, don't worry, okay? Be specific about any parts that you're not so sure. Type it into the Google form question, and then I'll take it up in class altogether. Okay, so I'm gonna keep practice this part in class, and you will be fine. See you guys in class. Thank you for watching.